Hey mate, welcome back to the workshop on the hill. Today, V10 BMW 6-speed sequential quaif. This is I think it's called a QBE69, pretty sure. It's the gearbox that over here in New Zealand we ran in the V8 Super Tourers. So yeah, there were 7-litre V8s, lots of grunt. This is actually one that was in one of my cars, a team that I ran. So they're a good thing. We had a few issues with them, but as soon as we started squirting oil into the gears and sorted out the flat shifting side of things a little bit better, the reliability did improve. But yeah, it was a big car, lots of grunt, big tyre, so they got a pretty hard time. But so this is out of one of our cars. So like I say, this is an S85 BMW V10 out of an M5, I'm pretty sure. So to adapt this engine to this gearbox was no mean feat. I've just finished off the bulk of it, and I just thought I'd give you a quick look. So first of all, I had to get a mock-up block, a dummy block. So the customer had one of those, luckily, so that was all good. I was hoping to be able to find a really accurate drawing of the back of the block face, all the pickup points and stuff. Couldn't find one, unfortunately, but I measured it up. There's, if you're really careful and sort of triangulate a whole lot of holes and double check yourself as much as you can, it actually came out really accurate, so I'm really happy with that. And also, as soon as you start measuring certain holes and distances, it pretty quickly becomes obvious that good old BMW gave us a nice round number from there to there and from there to there, and those are dead vertical, and even from the crank split line up to those holes, it was a nice round number. So as soon as you start seeing a bit of a pattern, you know that they've just done things simply. So once I got that, and I had once I got the gearbox, the next step then really was to figure out which bell housing I could use that the front face of it was similar enough to the back of the V10 that it's going to clear the flywheel and clutch, but also make sure that the pickup bolt holes for it fall relatively close to the factory bolt holes, so that you can the plate isn't too massive and the holes don't overlap. And it actually worked out really well. I'm pretty happy with the way that all came together. So then I had the dimensions of this face, the dimensions of this face. I could begin to draw this plate here in CAD, which took some time. It's always the way with this sort of job. You'll do it once and you'll finish it and you'll go, okay, that's good. I now know how to do it better, and draw it again. That's the way I do it anyway. One of the most important things about this plate, obviously, it needs to be thick enough so that it, when I screw into it, it's nice and grunty. It's got plenty of strength in the bolt thread, but also the crank angle sensor goes right there, which I don't have one at the moment, unfortunately, or else I'd show you, which picks up these teeth here for the crank angle sensor. So the flywheel that I got made had to have all of the teeth in the factory position, and the crank angle sensor had to be in exactly the factory position as well, with the correct air gap between the end of the sensor and these teeth. And at this point, nothing existed. This was all CAD. In fact, when I was drawing this originally, I didn't even have the bell housing yet. That was on its way from overseas. So just to get ahead of things, I started to get that drawing together, knowing that when it arrived, maybe it would need a few tweaks, but luckily the drawing that they supplied me was bang on. So that was nice. So then I got to the point where I was pretty happy with the adapter, but this is an expensive piece, so I didn't really feel like getting it made and it arrived just to figure out that I've actually made a little mistake. So what I did was I got it 3D printed. I got these sections of it 3D printed so that I could just mock it up enough and just the important bits, because if I got the whole thing printed it would cost 10 times what this cost. Yeah, so that I could put it in place like that. All the important holes were where they needed to be, and then I could put the bell housing onto it and measure up centers and everything and make sure that everything has worked out the way I wanted. And I could see that the crank angle sensor sat nice and closely to these teeth with that 1mm air gap, which most people seem to agree that that's the magic number. I can obviously shim it if I need to, but at the moment it's bang on 1mm. So, which is a great thing about CAD, honestly. I'm relatively new to it, but the more I use it, just such a powerful tool to be able to make something virtually and get it perfect before you've even picked up a tool is awesome. As long as your measurements are correct and the drawings are correct, then it's awesome. So once I had those 3D printed, I was happy with the results for those. Then I knew exactly how deep everything was going to be. So the depth from the back of the face of the block to the front face of the gearbox, I knew exactly what that measurement there was. So at that point, that meant that I could start to figure out how high where this clutch needed to sit in relation to the back of the block so that it lines up with the splines on the input shaft. Because it's one of those projects where you can't just go changing stuff. You're better off making things work. Like I could have gone and bought another input shaft for this gearbox, but man, that would have been really expensive compared to just making a flywheel to suit that input shaft. Also, there's plenty of these in New Zealand, and the input shaft, there's plenty of spares of those around. So if I went and got a custom made one and we ever broke it or damaged it, then we're screwed. So right from the start, myself and the customer agreed that we should try and make that gearbox work without modifying any of it, and that's what we have achieved. So okay, so then I knew where the clutch needed to go, so then I could make the flywheel height from the back of the crank to the clutch discs exactly where I needed them to be. So this is what I ended up with, and that goes right there, and there's my clutch at exactly the right height. Then the adapter plate bolts on like so, and I hope at this point you can see how much time has gone into this, because none of what I just described was 5 minutes. Every single step, especially like I said, none of this is cheap, so I was very much double checking, triple checking every single thing that I did to make sure that I wasn't about to blow a whole lot of money with a CNC guy, just for a billet adapter to turn up that wasn't right. So that worked out great. This is exactly the right height. You can see the starter motor bolts. The starter motor in these engines is in the V, so these cap screws go through into that starter motor. And there's also that little one there for the same reason. So at that point, really happy. Then I had to, I now had enough information to be able to buy the slave cylinder and know how thick I needed that spacer to be so that it mounts to the back of the bell housing and sits that slave cylinder about 1 millimeter away from those fingers, and that worked out really great as well. I'll show you that in a sec. as I said, that sits there, and as you can see, that clutch pack sits really nicely at the correct height, and the spigot bearing is going to be in the flywheel itself, because the original spigot bearing's like sort of another 20mm away from that input shaft. It's actually exactly the right size, but just too far away. So yeah, I've machined the flywheel to take a spigot bearing and put it in the right spot for that input shaft. So as you can see, this is the sort of job that sucks up time like no man's business. The gearbox is a pretty decent chunk of money. It's used, but very fresh, completely rebuilt, everything. But yeah, bell housing, clutch, release bearing, flywheel, and the billet adapter especially, just alone, they're plenty of cash, but the time involved in finding the correct bell housing that's going to work, the correct flywheel that's going to work, all of the dimensions to get that billet adapter bang on. I even got them nice and flush with the heads just because it makes my brain feel good. So yeah, that is where all the time goes in a job like this. It's it looks simple, and if I did it again, obviously it'd take far less time, but doing it that first time, like I said to my customer when he asked me how much it was going to cost, I said, well, let me go and have a look at the last time I put a sequential 6-speed quaif behind a BMW V10. Jokingly, of course, because I never have. So that's that little project. It's come out really good, and pretty soon the customer will bring the car, which is an E46 circuit racing car, and I'm looking forward to getting this into the car and hopefully doing some headers and exhaust and that sort of thing as well. I really want to make this V10 sing, especially when it's humming through the 6-speed. Yeah, could be a very nice sounding car and should go good too. So cool, thanks for tuning in, and look after yourselves, and I'll see you next time. Cheers.